Very good morning, student. Welcome to the SUTHAR'S point. Dear student, today we are taking very important unit, that is the probability. So here we see some more topic, as you are already know about the probability. From the 10th, 11th class you see the simple definition of the probability and some simple theories of the probability. Now we take one more theory and that we see how we can use in our different life situation. So let's see. So dear student, in earlier classes we have studied that the probability is a measure of uncertainty, and in the 9th and 10th class you see the classical theory of the probability, and in 11th class we have to see the axiomatic theory of the probability. And depending upon the axiomatic theory of the probability, we see that how the probability can be defined depending on the different axioms. Like we are saying about the random experiment, and depending on the random experiment, we also define or call the probability is a function which depend on the outcomes of any event. So in that case you have to use the different formula of the probability in 11th class, and also you see in 11th class addition rule of the probability, how we can add the probability of getting the event, and in that case you also see how to find the probability of the event of naturally explosive event and exhaustive event, and different type of topic you learned about, and also you see how we use the set theory in the probability. Clear? But here we have seen some more higher order topic of the probability. Like you can say here conditional probability. What is the meaning of conditional probability? And also we learn some more theorem like Bayes theorem or binomial theorem, how can they are used in the probability. And also we see here the binomial distribution or statistical distribution of the probabilities we have to find out. So this chapter we have very important topic. So first of all we see the conditional probability. So what is the meaning of conditional probability, that we have to see. So dear student, up till now in probability we have discussed the method of finding the probability of the events. If we have given two events from the sample space and we cannot say there is any effect of one event on other, that we are not considering. We are separately finding the probability of each event in a experiment. Clear? But here we have to see if any event affect the happening of other event, then what happen, or how can we find the probability. यानी अगर एक इवेंट का होने से दूसरे के इवेंट पे कोई फर्क पड़ता है तो उसकी probability क्या होगी, that we have to see here. So here experiment is given. Consider an experiment of tossing three fair coins. So we know that when we are tossing three coins at a time, so total possible outcome are 8, that are H or H T H or T H, or you can say H T T T or T or last will be T. 1 2 3 4 5 6 7 8. So total outcome are 8 when we are tossing a coin 3 times, or you can say 3 coin 1 time. Clear? So since the coin are fair and we have to see probability of each outcome is equal, as you have seen in 11th class, probability of happening any event equally likely. So that equal to Probability of each case is 1 by 8 because total possible outcomes are 8 out of variables in any one. Suppose you want to get the probability of getting all head, then it is 1 by 8. All 10, it is 1 by 8. That already see. Now suppose we take some cases of example to understand this topic. Let E be the event. E be the event. At least two heads appear. At least two heads appear. क्लियर? कम से कम दो हेड आते हो. E we take and F be the event. F be the event. That says first coin shows 10. First coin shows 10. So now if you find a variable outcome to E. So what E say? At least two head appear. So that are at least two. कम से कम दो हो सकते हैं, ज्यादा कितने भी हो सकते हैं. So H H T H T H T H H. So these are four variable cases. 1, 2, 3, 4. Clear? Now similarly, second first coin shows 10. Only first coin says 10. Other may be head or it may be tail. So F can have first should be T. So this is T. This is first T. T T. So you write all these T H H T H T T T H or all T. Correct? So this is again 4. Now if you want to find the probability of each one, means if we want to find the probability of E. So here this is probability of this 1 by 2, 1 by 2, 1 by 2 and 1 by 2. We add all these. So probability of E equal to, you can separately write either PHH plus PHHT and so on, like up to PTH. That is E is 1 by 8. 1 by 8, 1 by 8 and 1 by 8. So total will be 4 by 8, which is 1 by 2. Similarly, if you want to find the probability for the PF, so PF, so again the probability of THH plus probability of TST plus probability of TT. So this is also 1 by 8, 1 by 8, 1 by 8 and 1 by 8, which is also 4 by 8, that is 1 by 2. Clear? Here common also we are given E intersection F, as you see in the 11th class, that E intersection common to both, that is THH, only 1 point, THH. So if you want to find the probability of this event, E intersection F, that is also 1 by 8. Clear? Now we can see that very important result is here. Suppose we are given that the first coin shows 10, it is F occurs. Suppose we can say this event occurs first. First we are given that first coin shows 10, F occurs, then what is the probability of occurrence of E? So this is the condition. What is condition? If first coin shows 10, then what is the probability of E? E means at least 2 head appear. Means the condition is there. If first coin shows 10, then what is the probability that at least 2 head appears? So now you can say this first there are out of these favorable will be total possible outcome will be 4. Which one 4? Because if first coin shows the 10, it means favorable outcome or total possible outcome for F or E. So total possible outcome for E under condition is 4. Because why this? We are not taking this sample space. Why we are not taking this? Because condition is given. First coin should show the 10. It means how many cases are there? T. So there are 4. So this is total possible. If this happened, then what is the probability of happening of E? So here favorable total possible outcome is 4. So out of 4, which favor to E? How many favor to E? Means at least 2 head appear. So 1 only. So that is probability is 1 by F. So we can say probability of event E when F is already occurred, that is 1 by 4. Why 1 by 4? This is clear? Because when you take the condition that this should be first, it means this sample space we get first. So out of this you have to check how many cases are there where we get 2 head. So only one case. So favorable outcome for E this. Total possible outcome for E. For E means here F is already happened. So whatever you get the result of F, that are favor to E. So probability is 1 by 4. Clear? So additional information random access for with the sample space coins or consists in outcome only. So probability of E given that when event F occurs is 1 by 4. So this E is called the conditional probability of E. So this is known as conditional probability of E when F is already occurred, which is 1 by 4. So what is the meaning of conditional probability? That when one event is already happened, then what is the probability of happening of the second event? That is known as conditional probability. So how we write? This is symbolically E oblique F. E slash F. E means probability of E when F is already occurred. E oblique F we write. So this means the probability of event E. But when it is already F occurred. In general we know that probability of E is what? Without any condition, probability of E is 1 by 2. But when you use condition, the probability is less. Why this? Because there is a common point. That's why this. So conditional probability we can say very important. So note that element of F which favor the event E are the common element of E and F. So this is what we see here. We can get this one. What is the one? Which one? That is THH. It means that is in both. Either in E or F. In both. It will be in E as well as this. So we can modify this one and we draw a formula. So what formula? Note that the element of F which favor the element of E are common element of this, that is the sample space E oblique F. So this is favorable to E here. For conditional probability, the element favorable to E means the element which is common to E and F. Clear? So thus we can also write conditional probability of F. So conditional probability formula is conditional probability is equal to number of element favorable in E and F both, or you can say E intersection F upon number of element in F. How many element in F, or number of element favorable to F. So P E oblique F equal to number of element in E intersection F divided by number of element F, because this is 1 by 4. In E intersection F, how many element? 1. Element in F, that is 4. That's why the conditional probability is 1 by 4. Now if you divide the numerator and denominator both by the element of the sample space, number of element in S, both are divided by the same number, then there is no change in the value. But formula what we get? Now you can see the number of element in E intersection F divided by the sample space. Number of element in E intersection F divided by total number of element, that is here 1 divided by 8. So that is what? Probability of E intersection F. So this numerator you can write as probability of E intersection F. Similarly, NF divided by NS, number of element in F divided by the number of element in the sample space. So that is probability of F. This we have already discussed. So that is PF. So now you can see formula. Probability of E intersection F divided by the probability of F. So P E intersection F 1 by 8 divided by probability of F. Probability of F is 1 by 2, or you can say 4 by 8. Now you simplify this. 1 by 8, 8 by 4. That is equal to 1 by 4, which is our 1 by 8. So we get one more important formula. The conditional probability E oblique F is equal to probability of E intersection F upon PF. So this is the formula for the conditional probabilities. What is the formula? P E oblique F equal to P E intersection F upon PF. Clear? Or you can find by direct method, this like observation method you can find, or you can use this. So now here say definition. What definition says? If E and F are for conditional probability we see definition. If E and F are two events associated with the sample space of a random experiment with sample space of a random experiment, that will be say the conditional probability of the event E, given that F as occurred, that is, in symbolically you can language write P E oblique F is given by. So now we have a formula for conditional probability E oblique F equal to P E intersection F upon Pf, where Pf not equal to 0. Pf, because if Pf is 0, then it is not defined. Divided by 0 or number is not defined. That's why Pf not equal to 0. Clear? So similarly, if you see vice versa, means if you want to find Pf oblique E, so what is this meaning? The conditional probability of F when E is already occurred. So the formula will be same, only symbol will be changed, that is this. E is already happened, that's why we are doing. F is already happened. So in the denominator, we always write the probability of the event that already happened. Now we see some properties of the conditional probability. That is also very important. We use some formula based on the 11th class sets theory. So we can say properties of conditional probability. So first say let E and F are event. We are taking here in all, let E and F are events associated with random experiment with sample space S. Means we are given a random experiment whose sample space is S and there are two events A and B. Then we have some result. First property says P for that probability of S oblique F or probability is equal to 1. The probability of S means conditional probability of sample space when S is already happened, or probability of an event that happened already, we have to find again that one. Probability of F oblique F means probability of F again we want to find. We know that this first event is happened again, and then we have to find that one, that is equal to 1. Clear? So that you can say, as if you want to write the formula in the left hand side, as we know, if you want to prove this, probability of S oblique F, we use this formula, probability of E oblique F is equal to E intersection F upon Pf. So here E is replaced by S. So formula will be probability of S intersection F upon probability of F. And dear student, you know that F is a subset of S because S is the sample space of the experiment. Experiment में जितने भी output है, that you have to take in S. And E and F are events. So whatever output in the F, that are also output of the S. That's why S is a subset of S. So you know that intersection of a set and its subset is always subset. So S intersection F will be Pn upon Pn, which is 1. F is a subset of S. Clear? Similarly, you can use the formula same here. F oblique F. So P F intersection F upon Pn. So both are same element and their intersection is again F. So we are saying this is the first property. Clear? Then again second, if A and B are two events of sample space F, if A and B are two events of sample space S associated with a random experiment and S is an event of F. Also one we take more, and F is the event of S. Then we have to prove a formula, probability of A union B oblique F. Now we see in 11th class union and intersection in probability. So P A union B oblique F is equal to probability of A oblique F, probability of B oblique F minus probability of A intersection B oblique F. And if intersection is a phi, then particular case will be taken. So that particular case what says? In particular, if A and B are disjoint events. Disjoint event we see in 11th class. Two events are said to be disjoint if they have no common element. Then what see, then this formula will be converted into A union B oblique F is equal to P A oblique F plus P B oblique F, because their intersection is 0. So probability will be 0. So that's why we can say that in particular case. Now we have to prove this. Again using this formula. So if we are using this left hand side, that is this one. Probability of A union B oblique F. So here we can take this as E. And in this formula, E means A union B. Oblique F, oblique F. So you can write use this formula, E intersection F. Now E is replaced by A. So probability of A union B intersection F upon probability of F. Clear? So this will be there. Probability A intersection F. Now we can use the formula distributive property of the intersection or union as in 11th class. So we can write P A union B A intersection F union B intersection F. F intersection A, here union, then F intersection B upon P. Now again you use the property In the set theory, this is suppose x and this is y. So probability of x union y, probability of x union y. So probability of x plus probability of y minus probability of x intersection y. So what we write? Probability of x means this only, y means this. So probability of x means a intersection f plus probability of y, that is b intersection f, minus probability of x intersection y. So x means a intersection f intersection b intersection f. So all have common a intersection f whole intersection of b or intersection. So you may write as a intersection b intersection f. So moreover you can write is whole divided by pm. So this we get the formula again, same. So what we get? This can be in reverse order. If it is given PE intersection F upon PF, we write this. So here what given? PA intersection F upon PF. So A probability of E, F is already happened. So this first can be written as PA oblique F. Similarly this formula. So probability of B when F is happened minus, now this you may also write like this, P A intersection B intersection F upon P F. So again here also we use this P as a replace as A intersection B. So this can be written as P A intersection F plus P B intersection F minus P A intersection B oblique F. So that we want to prove. So in this way, dear student, one can prove the different formula. Now particular case, when A and B are disjoint event. So disjoint event, that is A intersection B equal to, they have 5 as a common. So probability of that one, as we see in 11th class, that will be 0. So in this formula, if you put this 0, then what left? This. So therefore, P A union B oblique F equal to P A oblique F plus P B oblique F. So dear student, when two events are disjoint event, in that case you can say probability, conditional probability for union A union B when F is already happened is equal to P A F already happened plus P B when F is already happened. So dear student, in this way one can find the probability of each event. Now next property, that is property third, we see. So that is also very important. These are properties. You may further use these properties to calculate the probability of the some theoretical examples or problems. Like third say P3 probability of E naught oblique F equal to 1 minus probability of E oblique F. This is very important. So by first property what we learned? By P1 we learned that probability of S oblique F equal to 1. Probability of S oblique 1 equal to 1. Now S means what? E and E naught. Probability of E union E naught. If there is only one event, then S is equal to E union E naught. E and E naught. That make again sampling. Event and not event. That is S. Clear? Now you know that E and E naught are disjoint event or complementary event. These are disjoint event. So we know that if they are disjoint event, then their probability is or common is 0. Or we have made this particular case where A and B are disjoint event, we get only this formula. Clear? So here this one is disjoint event E and E naught because they have no common points. That's why you can use this formula. So that is P E naught oblique N. This is equal to 1. Now use P E oblique F plus P E naught oblique F equal to 1. Using this formula, P A union B oblique F equal to P A oblique F plus P B oblique. Correct? So what we get this one? Now if you want to ask this on the left hand side, so you transfer this right side. So what we get? P E naught oblique F is equal to 1 minus P E oblique F. That we want to prove. Clear? So in this way we have to prove some problems of the conditional probability and some property we see, and also we see one formula, only one formula is there. Other all formulae we can draw on the basis of the knowledge of the 11th class. So we see some more example of this one. So that is very important. One question of 2 marks or 3 marks may be asked from this one. So if PA example first is if PA equal to 7/13 and PB equal to 9/13 and PA intersection B equal to 4/13. This is B1. Correct? Then say evaluate P, very easy question. You have to evaluate P A intersection B. That is conditional probability you have to find out. 3 probabilities are given. So as we know that in solution we write conditional probability A oblique B is equal to P A intersection B divided by PB. Put the value 4/13, value of this upon PB 9/13. So that is 4/9. So in this way you can use, these are the direct example is given. You have to use the formula and you get the answer. Next one, see example, that is very important. A family has 2 children. Example second, a family has 2 children. Question say, what is the probability that both the children are boys, given that at least one of them is a boy. So very interesting topic, common and very interesting topic. So what says a family has 2 children. So you can say solution, let B stand for boy and G stand for girl child. Clear? This we are symbol using the sample space of the experiment. The sample space for the experiment. So what possibilities are there? If there are two children, then what possibilities that we can say both are boys? First child is a boy, second is also boy. First is boy, second is girl. Or first is a girl child, second is boy. Or both are girl child. So there are four possibilities. Four type of possibilities. Clear? Now there are two events. Let E be the event. What we want to find, that we take always E. A family has two children. What is the probability that both the children are boys? So then you have to suppose E always. So it is easy. So event E, what E? Both the children are boys. This is, and F what? That already happened. That you have to see. What happened? Given that this. At least one of them is boy. At least one of them is boy. So outcome for E, possible outcome for E, that says both will be boy. Both children are boys. So how many cases? Only one. So you can write here B. F what says? At least one of them is boy. At least one. Again this B. Or it may be GB. Or it may be B. So now common to both E and F. Common to E and F is only one point. That is E. Now you use the, we want to find what? E oblique F. That is probability of E intersection F upon PF. So what is the probability of E intersection F? E intersection F. 1 point common, total sample space point 1, 2, 3, 4. So 1 by 4. Also we need the probability of F. So in F how many? 1, 2, 3. 3 upon total of the sample space 4. So these values you have to put in the formula. 1 by 3 by 1 by 4, then 3 by 4. So 1 by 4 into 4 by 4. That is 1 by 3. So in this way one can get the value as 1 by 3. So this is the probability that the two children are boys, and if it is given at least one of them boy is already up. So in this way one can find the probability or conditional probability, which is very important. Clear? Then you have some more problem that we see in the next time. So dear student, this is for all today's class. So you can see here the probability, it is very important, particularly this conditional probability. In many competition exam you have also find the question related to the conditional probability. So have a nice day and thanks for watching, and to be continue with us for more interesting videos.